The figure above shows part of the curve C with the equation y equals 3x to the power of a half minus x to the power 3 over 2, where x is greater than or equal to 0. The point A is on the curve and is a stationary point, and the curve cuts the x-axis at point B. Part A, show that the x-coordinate of B is 3. So I need to show that this coordinate here is the point 3. Well, at that point, I know that the y-coordinate is equal to 0. So if I take my curve, the 3x to the power of a half minus x to the power of 3 over 2, and if we make that equal to 0, we can factorise the x to the power of a half outside, like that. Just double check this, the x to the power of a half times 3 does give the 3x to the power of a half. The x to the power of a half times the minus x does give the minus x to the power 3 over 2. So therefore, either x to the power half equals 0, so x equals 0, which we know from over here, or the 3 minus x equals 0, so x equals 3, which was what we needed to show. Part B, we need to find the coordinates of point A. Now, we were told about point A in the question. We were told that point A was a stationary point. So that means that at that point there, we know that the gradient is equal to 0. So if I take my function and differentiate it, so we're going to multiply by the power and then take 1 away from the power. So we will have 3 times a half, which is 3 over 2, and then the 1/2 minus 1 is minus 1/2. Then for the minus x to the power 3 over 2, we're going to multiply by the 3 over 2. And then take 1 away from the 3 over 2 power. 3 over 2 take away 1 is 1/2. So this is my gradient function, and I want to find when does this equal 0. First thing I'm going to do to make this a little bit simpler is I'm going to multiply through by 2 to get rid of those fractions. And whilst I'm at it, I might also divide through by 3. That's going to make it even easier. Now, to solve this, I don't like this negative power here. Those negative powers are good for differentiation, but quite tricky for integration and quite tricky for solving equations and things like that. So I don't want that to be there, so I'm going to rewrite this like that. And hopefully it's clear now what method I need to use. I need to multiply through by the x to the power of a half. So if I times each term here by x to the power of a half, the 1 over x to the power of a half is just a 1. The x to the power of a half times x to the power of a half is x to the power 1, or just x. And obviously the 0 times x to the power of a half will be 0. And now I can see that x is going to be 1. So x is 1 at point A. And then if I substitute that into the original function, so if I do 3 times 1 to the power of a half minus 1 to the power 3 over 2, I find out that the y-coordinate is 2. Then we'll move to part C. So I'll just clear a bit of space. Right. So part C says, find the exact area of the finite region enclosed by the curve and the x-axis shown shaded in the figure above. So the exact area enclosed by C, which is this, the x-axis, which is this, and so therefore this is the shaded area we're trying to find. We can find that by doing some integration. We are going to be integrating from the lower limit of 0 to the upper limit of 3, and our curve is the 3x to the power of a half minus x to the power of 3 over 2 with respect to x. To integrate, we're going to add 1 to the power and divide by the new power. So if I add 1 to the half, I get 3 over 2, and we'll divide by that new power, so we'll divide by 3 over 2. The 3 over 2 the 3 divided by 3 over 2. Well, dividing by 3 over 2 is the same thing as timesing by 2/3. 3 times 2/3 is 2. And the 1/2 plus 1 gives the 3 over 2 as the power. So 3x to the power of a half integrates to be 2x to the power of 3 over 2. Second term, again, we're going to add 1 to the power there. So 3 over 2 plus 1 becomes 5 over 2. 3 over 2 plus 1 is 5 over 2. We're going to divide by that new power. We're going to divide by 5 over 2. Dividing by 5 over 2 is the same thing as multiplying by 2/5. So we get 2/5 of the x to the power 5 over 2. We're now going to substitute the upper limit of 3 into this. Then we're going to substitute our lower limit of 0 into this. And we're going to take them away. When we do that, we find that the exact area is 12 over 5 root 3.